Today we're going to talk about a couple of things. First of all, we'll go into some fundamental things from CLion, and we're going to talk about stepping, viewing, watching variables and expressions, breakpoints and conditions. Then we'll go to Thing, and we'll see how the plugin for CLion works, and talk about reversible debugging, and then come back to more advanced CLion debugging topics like attached to local process or remote debug. We'll make actually a stop after each path to check your questions. And now I'm going past to Phil.
Hello. So thanks for that introduction. Now I'm sure everyone here is all tuned in to hear the main event with UndoDB's reverse debugging, and we'll definitely get to that. But I think it is definitely worthwhile to just get a nice grounding and just go over again the fundamentals of debugging in CLion. Sure, most of you are familiar with debugging, if not in CLion, then maybe on other platforms. But it's definitely useful to just know your way around, know where to look for things, and there's one or two nice little extras as well that you may not be familiar with. So let's get started. I've got CLion open here. You can see I've got a code base loaded up, and it's the catch test framework. Though I wrote catch, so I'm familiar with this code, so I thought it was a useful example. And what we're going to do first of all is all of the debugging features are going to be available from the run menu. So that's the first place you can go and look when you want to see what's available. So we can see that a number of the options are grayed out because they're only available when we're actually running. We'll get to those ones. Now there's a few options up here: run, debug, and also run and debug with a configuration name. Now the reason there's two here is because if we go to run here, we get a choice of configurations, and we can either choose a particular configuration. We only have one here, or we can run all configurations. We go back to the menu. So for convenience, because you're usually just running one configuration, then the run and debug options will just run or debug the last configuration that was run. So you'll usually just use those. So if we do run, and we'll run self-test, we can see that the program just runs through. So we'll do that again, but we'll do debug. And this is just to make sure that we're actually debugging the right configuration. And now we can see that's just run through as well. The reason being because we haven't set any breakpoints, so it's not going to stop anywhere just yet. So we're going to fix that. But before we move on, I just want to make one more point here. We've been using the run menu because that's where we can go for all of the debug options, but it's not a very practical way to go about debugging, to keep coming back here. So do make a note of all the keyboard shortcuts that are listed in the run menu and in other places. I'm running on a Mac here, so these shortcuts are specific to Mac. You'll see different ones on different platforms. So let's get started. I'm going to set a breakpoint just here. We'll come back to breakpoints in a moment. And this time I'm going to use the shortcut to debug, which is Control-D on my Mac. And that will run now to that breakpoint. No surprises so far. But now we can see that the debugging tool window has come up. That will come up automatically. We can bring it up any time by going to View, Tool Windows, Debug. Again, you can see there's a keyboard shortcut. In this case, it's Command 5, so we can toggle that in and out. Now, like most IDE debuggers, Tool Window is organized around a stack trace, so we can look up and down the stack. And over here to the right, we can see the variables that are currently in scope. If we have a look inside some of these, we can see primitives and simple value types actually show directly in the debugger. That there are visualizers for types like standard string, for example, or we can open up and have a look at the detailed implementation. But usually just the visualizer view will give you all you need. Now there's a little bit extra here as well that you may not have seen in other IDEs, because when we're at a particular scope, the variables are also shown directly in the code. We can see here the value of x is given, It's the same as the one down here, but when you're looking at the code, it can be convenient to see at that particular line what its value was. And here that's really useful because we're adding floating point numbers together, and you can see that that rounding error shows up very clearly here. We can see why we need this this fuzzy comparison here. As I said before, if we go up the stack, we can also see the variables that at different levels. If we go to this level, you can actually see that the inline variable view also works for class member variables. So most of these are pointers, which are not so useful. But have a look down here and you'll see the standard vector. That's also showing us the size. That's because that has a visualizer too. So the visualizers also show in the inline variable view. So moving across now to the left-hand side, we see a number of icons here. We have a resume program. Again, you can see in the tooltips that it also shows the keyboard shortcuts, and I really recommend you do learn as many of these shortcuts as possible. It really will make your debugging life a lot easier. We can stop the current execution, and then we have some options to do with breakpoints that we'll come back to in a little while. And some more icons across the top. These are the stepping icons. These are really the bread and butter of debugging. I'm sure you're familiar with how most of these work. So we have the step over, step into. This one may be a little bit more unusual, false step into. And that's because normally when you're stepping, you'll step to every line of code. But there are certain areas of the code base, particularly libraries, especially the standard library, you don't want to be stepping into all the time. So these can be excluded from the debugger stepping. But full step into will step into those as well. So you still have the choice there. And we have step out and run to cursor. Okay, there's one other option, that's right. Evaluate expression. So as well as looking at the variables that are currently in scope, we can actually start typing directly, and if I spell that right, we should get code completion. There we go. So if we now evaluate that, we can see the result in our expression evaluation, and we can add that to our watches. So watches will appear alongside our variables, but they could be more complicated paths to get to our values, so they can be useful. And they'll also show up regardless of what stack level we're looking at. And we can manage those by removing them from here as well when we want to clean up afterwards. Okay, so let's have a look at a bit more detail on the breakpoints. So coming back up to the run menu again. So there's a number of ways that we can set or toggle breakpoints. We can use the menu option, but I wouldn't recommend that. But that's showing that there's a keyboard shortcut, in this case Command F8. So let's use that. While we're on this line, we can Command F8 to set and unset, or we can do what I did before, which is just to click directly in the gutter. So there's a couple of ways to do that. And I guess more interesting, if we come over here to View Breakpoints, so bring up our Breakpoints Manager window. Now what we've been looking at so far are all line breakpoints, which is what you'll use most of the time. So we'll usually stop on a particular line. We set one so far. If we go to the options, we can see there's actually quite a few options here. The default behavior is to suspend execution when we hit a breakpoint, what we'd normally expect. But we don't have to. There's a few other things that we can do when we hit a breakpoint. For example, we can log a message to the console. This can be really useful if you're going to hit a breakpoint lots of times, hundreds or thousands of times. You don't necessarily want to be manually stepping through that all the time. So just seeing a message on the console is all you need. And there's a variation on that. We can actually log a message when we hit that breakpoint. We can also set a condition of what values need to be in a particular state before the breakpoint will be hit. So if I for example. I've done that again. Use that same example before. Now we can say this will only be hit when this variable has a value of 7. Or we may want to, instead of doing that, let's actually evaluate that. You can see in all of these views we have code completion, which makes it a lot easier to get this right. So if we do that now, and we'll run this again, so I'll stop that. Now this icon at the top I didn't mention before, that will just rerun the last configuration. And now we can see it's printed out the values as it's passed through that breakpoint. So that can be really handy. Let's go back to our breakpoint view again. Now we also have an option to remove once hit, so we can have it only run once. You can see here it's run twice. So we run that again. That didn't work. Okay. I'm not sure why that didn't work. Let's move on. The more interesting one for me, at least, is disabled until selected breakpoint is hit. So you can select another breakpoint here. Now we don't have any other breakpoints set at the moment. But what this will let you do is we'll only trigger this breakpoint if another breakpoint is hit first. So you can actually define different paths through your code, and the breakpoint will only be hit if a certain path is followed. And you combine that with the option to not suspend when you hit a breakpoint. This can be a quite nice way to get to those really hard to reproduce bugs. So moving on, we have that was line breakpoints. We also have exception breakpoints, which, as you would expect, are breakpoints that are hit when you throw an exception. But you can also hit them when their exceptions are caught, or both. And you have most of the same options again. We can log a message to the console. We don't have to suspend. We can remove once hit, and we can have these dependent breakpoints as well. So let's disable those again. Now you notice there's 2 more exception breakpoints here. These are actually coming from plugins, so they may look different in your particular setup. I just happen to have plugins for Python and JavaScript installed. They show up there. If we look at one of those, you'll see that, again, we have most of those same options again, and also some options that may be specific to the particular type of plugin. But that's pretty open-ended, so we're not going to look into that too much at this point. Okay. Now I wanted to no, I think we'll come back to that. I think at this point we can probably finish here for now. We'll hand over to the undo guys, and we'll come back a little bit later to look at a couple more options in CLion. So over to you.
Yeah, thank you, Phil. So we've got just a couple of questions. I think first was mostly about catch itself. So the question was mostly what's the difference between require in comparison to assert. So maybe you could just comment about the catch just a little bit, just to introduce it to the all the attendees.
Okay, I should have realised I'd opened myself up to that. We won't spend so long on catch questions, but yeah, simply the difference between require and check is that if a check fails, execution will continue. If require fails, it will actually abort the test. It's as simple as that.
Yeah, thank you. And I think that the question about the Python and JavaScript was mostly covered by Phil. So yeah, you could see these points in the list of breakpoints just because you have the plugins bundled into CLion. So Python and JavaScript, they are just bundled into the usual package. So you see this in the list. And that doesn't matter that if you have some Python or JavaScript code in your application or not, but maybe that could be a good thing to switch off. We could consider it for the future. So thank you, Phil. I'll now pass it to Isa and Greg, and they will tell you about the undo reversible debugging.
Hello, everyone. I'm Greg. I'm co-founder and chief exec at Undo. I'm going to give a little bit of a a background introduction to what we do, why it might be interesting. But all the really interesting stuff is going to come from Isa in a minute when she takes over from the slides and shows the real stuff. But a couple of slides then just to kind of set the scene. So this chap had as good a claim, I think, as anybody to having been the world's first programmer. Right? He was the first person to write code on a general purpose machine that did something other than just like verify that the machine worked, right? Did a real job. And in his memoirs, he says something that I think anybody who's done programming, either professionally or just for fun, will be very familiar with. And he says that he remembers very clearly when the realization came over him that he was going to spend a good chunk of the rest of his life fixing bugs. Basically, bugs as a term wasn't invented then, of course. But and I think we've all been familiar with it, as I said. And so programming is hard. And what's hard about it is that it never does what you think it's going to do. And the more complex the code gets, and the more that software eats the world, just the bigger this challenge becomes, right? And so I think that's why this webinar is really important. It's all around debugging code. Programming really is debugging. But I've heard it said, someone said that there's the writing the code is the bugging part, and then debugging is what you spend most of the time doing. So let's look at how we've obviously seen a lot of features through CLion and how that can be used with a more kind of conventional way of debug. But we're going to start looking at what we can do in the undo world. So I kind of said that slide, so I'll skip on. So when you're debugging, you need to know, really the question is, what just happened? Right? What did my software really do? I know what I expected it was going to do, right? And that's why I wrote the code like that in the first place. But clearly it did something that I didn't expect. So the question is, what did it do? And obviously it's produced some unexpected result. That's why we're debugging. But what led to that unexpected result? Very often, at least the times when it's anything other than trivial, the problem lies some way in the past. This happens sometime before the unexpected result. So you need to be able to figure out what's happened. And what we conventionally do is basically we run the program lots of times, right? Lots of trial and error, teasing out that data. The harder the bug, the more times we rerun the program until eventually we home in on the root cause, right? And that's in the best case that's very inefficient and unproductive, and in the worst case it just doesn't work, right? Particularly when your software is non-deterministic, when your program does different things different times it runs. Maybe it fails only one run in a few hundred, or maybe it fails every time, but each time it does it in a different way. And in that world, rerunning it multiple times kind of doesn't help, right? Often. So we need something better, and what we need is something like CCTV for code, right? So just as a detective would, in the old days, would be forced to kind of look at the crime scene and maybe look at a dead body on the floor and a smashed vase or something, and try and figure out backwards by some brilliant Sherlock Holmes style deduction what happened to get here. These days we can just look at the CCTV. We can wind that back and forward and we can see what happened rather than guess. And with reversible debug, you can do that, exactly that kind of style of investigation, right? So we can now see what happened rather than guess. And we'll see this in action in just a minute, which is, as I say, the really interesting part. But perhaps it's just useful to think about, why that matters. And I think actually it matters for these three main reasons here. So down the bottom, actually, got perhaps the most obvious, which is productivity improvement. And we've actually got independent studies from Cambridge University that show that this improves development productivity by a really significant amount, right? This is overall development productivity by 25+%. Not many things you can do to make that kind of impact. But I think perhaps even more important is the ability quickly to respond when things do go wrong. So when you get that very angry phone call from the customer, whether that's a customer inside your organization or somebody outside, how do you respond quickly to that? How do you get them up and running? And this kind of technology can really help you do that. And I think maybe most important of all is improving code quality, fixing the issues that otherwise don't get fixed. So it might be because you get that call about something that fails one run in 50, and you just can't get to the bottom of it, and you just say, oh, well, okay, we'll just keep going. Hopefully that won't happen again. Or it might be in test, right? And in your CI environment, or whatever kind of automated testing you're doing, hopefully you're doing at least some automated testing. And I think pretty much every software development organization is familiar with the issue that you have some failures in your automated testing, and your automated testing means that you're running thousands and thousands of tests every minute, every hour, every day, certainly. Even a small number of failures can be difficult to triage, a small percentage of failures. And what tends to happen is we have some tests that fail some of the time, and nobody knows why, right? And they just kind of accumulate, and you get this accumulating technical debt, which isn't technical debt as in like stuff in the code that's ugly, but it's debt in terms of I have failures in my test suite that I don't really understand, and they just grow and they lurk. And we let them do that because maybe 9 out of 10 don't really matter that much in practice. They're a problem with a test, infrastructure problem, or some esoteric combination of circumstances. But the others, the other 1 in 10 or whatever it is, really do matter, right? And they're your production outage or your security breach, just waiting to strike, right? And so being able to fix these problems in test before it goes out the door is really important. So that's kind of the background to why we think this is important, why we started the company, what we're trying to do. But I think the more interesting stuff is for me now to hand over to Isa, who can show you what it actually is.
Okay, thank you very much, Greg. So let me switch over to my CLion window. Okay, so I'm just going to put CLion into presentation mode, which just makes the text bigger. And I'm going to start a debugging session to get the buttons up at the bottom. So I'm going to start off just by talking you through the buttons that we've added in the plugin and what they do. And then I'm going to show you a demonstration of how you can use these to find a real bug in this example program that I've got here. So first, the buttons. So you'll see here that there are the usual familiar forwards debugging buttons, which Phil showed you earlier. But as well, with the UntiDB plugin loaded in CLion, we've also got these analogous backwards buttons here. So we've got reverse step over, reverse step into, and reverse step out. As well, we've also got over here, this is your normal go forwards resume and reverse resume. So I'm going to be showing you how to use these buttons. So on my screen, I have a small program. So if I just scroll up and down a little bit, you can see it's very small. It's only about 100 lines long. I'm not going to go through in detail what this program does. I'm just going to give you a quick overview now, and we'll learn a bit more detail as we debug it, because that's quite often how it is in the real world. You don't really know what you're debugging until you're deep in it. So the main function that we're interested in is this cache calculate function. So this takes a number and returns the integer square root of that number. It does this by looking in a cache to see if the number's already been calculated. If it hasn't already been calculated, it populates that number in the cache, and it populates one number either side of it. The main function is just a test, which repeatedly loops through, generating random numbers, calling our cache calculate function, calling the clibrary square root function, comparing the two results. If they're wrong, if they don't match, it prints a message and it assert fails. So at the moment, when I said start debugging, I'd set a breakpoint at the beginning of main, so we've just stopped there. So all I'm going to do is I'm just going to say resume, and we'll just see what happens. So if I go over to my console here, we can see that lots of iterations, so this is just the output from the program, lots of iterations successfully ran, but we got to a particular iteration where we tried to calculate the square root of 255, and our program told us that the result was 0, which is obviously not right. The correct result would be around about 15. we printed out this message, the assertion failed, and we had a stick abort. So we know that there's a bug here, and we're now going to use reverse capabilities to go backwards and find out what it was. So if I go back to this debugger tab here, you can see that we've ended up somewhere deep in the C library. And that's not good for debugging. We don't have source symbols, and it doesn't tell us anything about our program anyway. So the first thing I want to do is get out of the C library. So to do that, I'm going to use reverse step out. So if you can see, each time I click this, we go up one level in the call stack. So I'm going to keep doing that until I get out of the C library and back into my own code. So I can now use reverse step over to go backwards, line by line. So at this point, I haven't learned anything new yet, because I knew that this failed and I knew that we printed this message. Go back one more. I know the only actual interesting thing here is this cache calculate function, and I know that that's what's misbehaved. So instead of stepping over it, I want to step backwards into it, which I'll do using this button. So that's taken us to the closing brace of cache calculate. Scroll it and show you that. That's not very interesting. Let's go back one more. Okay, so this is the return statement which caused us to exit this function. So we've returned something which we think hit in the cache. So let's find out what's going on here. So the first thing I want to do is find out which entry it was. So let's have a look at I. So I is 90, so it's the 90th entry. So let's look at entry 90 and expand this structure here. So each entry in the cache is just a simple number and associated square root. And we can see here that indeed this cache hit has returned this wrong value. So we've got this fact in our program that's been somehow populated previously that the square root of 255 is 0. And this is really bad news, right? This is some kind of data corruption. So what we need to do is we need to find out where this bad 0 came from. And with normal techniques, if it was me, I think I would probably do it with printfs, add a load of logging and try and spot it that way. You could also set lots of breakpoints and run forwards lots of times. But with reversible debugging, I can just go straight to the source of the problem. So to find out when this last changed, I'll add a watch point. And that's all fine. Lifetime stack frame, it doesn't matter because this is a global. So I say done. And then I can just say reverse resume, and that will just go backwards until something interesting happens. Okay, so we've hit the watch point, which you can see because our little breakpoint thing has a little eye on it, an eye for watch. And you can see down here that we've written number in. So we've written in 255, but we've got the old value in square root. So let's just step over that line forwards. And we can just see we've confirmed that that's definitely the line which has caused the problem. So you can just do a little step forward, step backwards, just make sure you've definitely found the right place, which we definitely have. So this is where it's all gone wrong. So let's try to find out where the bug is. Let's go backwards a bit more. So I need to find out where this square root 2 has come from. So this line here, square root, is the square root of number 2. So what's number 2? Okay, so number 2 is -1, which is obviously a disaster for an integer square root function. So where has this come from? Where has this gone wrong? It's just on the line above. So number is obviously 0. So what's happened here is that we've completely legitimately tried to find the square root of 0 using our cache calculate function, but this attempt to populate one number either side of it is incorrect. It needs an extra check to make sure that we don't underflow and we don't end up with a negative number being passed to the square root function. So that's all I'm going to show you. For a small program like this, there are other ways of quite easily finding these kinds of bugs. but this is in fact based on a real customer bug in a more complex situation, but the same underlying principle. So I hope you can see that this does scale up and make finding impossible bugs possible. So that's me. Thank you very much. I'll hand over back to Anastasia and see if we've got any questions.
Yeah, thank you. Thank you, Isa. Yeah, we have actually a couple of questions around the plugin and the Undo technology. So first one was maybe you could give us some short overview, some idea how it works actually, because the question was like, is this like moving extension instruction pointer back? So maybe you could just highlight some ideas behind the technology.
Okay, so the first thing to tell you is that undo DB does not actually undo anything. So our technology is based on deterministic record and replay. So on the first run through your program, we record just the bare minimum amount of information needed to be able to replay it afterwards. So we show you going backwards by going forwards, basically.
Okay, thank you. The next question was, if these tools operate with a remote debug with the remote target. So CLion itself works with remote debug, and Phil will go with that later. So maybe you could comment about undo here.
Yes. So undo, you can do local debug like I've just shown. You can also do remote debug, and you can also attach to already running processes, which I think Phil will also show. So anything that you could do with GDB, you can do with UndoDB. Okay?
Yeah, perfect. Perfect, thanks. And the next question is, actually, where is the stack? So can you jump to a specific stack frame here?
So you can navigate up and down stack frames, I guess, by using the ability to step in and to step out. So in normal debugging, you have the ability to just click stack frames and move around. So we do that in just exactly the same way. Does that answer the question?
I hope yes. So if not, we'll just proceed later with more comments to the topic. So another question here is if recorder is always enabled during debug session, or it should be switched on and off manually.
So either. So in this case, recording was enabled for the whole time. That's the default, but you can postpone it and then enable it manually when you're ready.
Okay, thank you. And maybe just the last question before we go next is, does it freeze one thread or the whole state of the application?
It records all threads in the application.
Okay, thanks. So I think we have some more questions here, but we'll just proceed with them later, just maybe in the end after the next part from Phil. So I'm passing the screen to Phil right now. Okay. And then we'll come back to some questions later. Thank you, Isa.
Okay, thank you, Anastasia. So hopefully that's showing my screen again now. Back where we were a little while ago. We're now going to look at attaching to a local process. So far, all of the debugging we've been doing, we've been starting from within the IDE, so we haven't had to do that step separately. But if you've used any other debuggers, you probably used attach to process before as well. Very useful if you've got a process that's already running, maybe it's been kicked off by some other application or service, or there's some other reason you couldn't initiate it from within the debugger. So what we're going to do here, I'm going to switch to another screen. Hopefully you can see that. I've got a console window here. Now I've got the same version of the catch self-test application that we've been looking at. But there's a particular test that I set up that I've called it long running because it does just that, it's not returning. And we want to find out why. So while that's running, I'm going to switch back to the IDE, and we're going to go again to the run menu and say attach to local process. And we can see we've got all of the processes available in the system. We don't want to have to go through that list, so I'll just start typing and it will narrow it down to just the one actually that's running. That's now attached, but it's still running, of course, because we don't have any breakpoints set. Well, we can pause, and that will now stop the execution wherever it is. And you can see it's actually somewhere down here in the standard library, releasing a shared count. This is all grayed out because we're choosing to exclude the standard library calls. So it's actually left us directly in our code, which happens to be the catch framework, which is probably what you want most of the time. And of course, we can move up and down the stack. This is actually in the framework code here. We get up to the test case that was causing it. This is the one that I added. And we can see that we're in a loop. We're meant to be going between 100 and 0 backwards, but we're using an unsigned integer, and we're comparing greater than or equals to 0. And so, of course, it's missing that. And we can see our inline variable showing us we've got a very high value for I, because either that should be greater than, or maybe we meant to use an int. So we found our bug very quickly. No reverse debugging required in this particular case. So that could be very useful. So that's debugging a local process running on the same machine. Let's stop that now. Now, as we alluded to earlier, we can actually debug processes running on another machine. We have a number of configurations currently supported. The main one that was added in the previous version was going from a Mac to Linux. We also now support Windows as well. I'm going to go from my Mac to a Linux virtual machine because that's going to be easier to demonstrate. So if I switch back to my other screen again, and I'm going to drag in a Linux VM that I've prepared earlier. So I'm going to type my password in, so look away. Okay. So I've got this just all ready to go. You can see I'm in I've got another build of catch here. We're in this directory where the self-test executable is. And what we're going to do is we're going to run GDB server. We're going to run it on localhost because we're on the same network. And I'm just going to run the self-test executable. So if I run that, it doesn't actually start running just yet. It's waiting for a connection from the remote debugger. So let's now switch back to CLion. And if we go out to the configurations, we didn't talk too much about configurations earlier. We can edit those, and we can see we can set the executable program arguments and so on. Now I've added an extra configuration for this purpose. It's a GDB remote debug. I called it remote catch. And we can see there's a few things we have to set up here. First of all, we need a version of GDB that's going to support this process. So it has to be this 64-bit Linux aware version of GDB. There are instructions on how you can get hold of that on a blog post on the JetBrains website. Then we also need to tell it where the remote application is running. So we're going to give it the IP address and the port number that it's running on. Then we also need to give it a symbol file, which can be a separate symbol file, or in this case, it's just the executable that was built on Linux, and I've copied it over locally here, so we have the same symbols. So you can do that either way. And then just to make sure we get the source code as well, we produce a mapping between where we have copies of the source files locally and where they map to on the that's the local machine, and then on the remote machine. So files under there should match up at the same level of the hierarchy. So that's the configuration. Now we've got that, we can come back up to here. So if we now say debug here, remember I said earlier that we then get to choose which configuration to run? This time we need that because we want to specifically run the remote catch configuration. That is now connected. And if we switch back to Linux, we can see now it's remote debugging from this host. So that's started. So back in CLion, again, we can pause. And we have exactly the same views that we had before. We can step up through the stack trace, find our test, and it's the same problem we had before. We're stuck in that infinite loop. We found it in exactly the same way. We even had the inline variables available. Everything works exactly as if we were running locally, except this is actually debugging now on the remote machine. And from what Isa was saying earlier, this should work exactly the same way with undo DB, because it all works over GDB and GDB server. And that's all I have to show you. So thank you very much.
Thank you, Phil. So we have actually some time to handle more questions, mostly about undo technology. So maybe Isa could help us here. So please unmute and we'll go through some questions. So the first question here is actually about the scalability of the solution. So there were lots of questions about if I need to record for a whole day or the bug is actually happening quite rarely. So how scalable is the solution? So how much memory it requires? So could you comment here?
Sure. Yeah. So we expect the slowdown to be around about between 2 and 5 times. So your application may run sort of at half the speed as you would expect it to normally. So there is a slowdown, of course, and there is memory requirements as well. But it's very important to us that it's usable. So, for instance, you can run programs like Firefox, and they're still completely interactive. You can interact with them. You can type things in. You can watch a video on YouTube, and things like that. So the slowdown isn't too bad. And we work with some companies who have got extremely large applications, sort of big databases and things like that. And so hundreds of threads and gigabytes of working set. And it works with that. So, yep, I hope that answered the question.
Yeah, sounds impressive. Thank you. And the next question is actually about can we replay events like interrupts? So is it possible to catch such things?
Yes. So interrupts on Linux are signals, and we catch signals. So if you're recording and an asynchronous signal or an interrupt arrives, we record that happening. And when we replay or when we sort of reverse the signal, the time that the signal arrived when you recorded it is the exact time that the signal appears to arrive when you replay it. Okay?
Okay, thank you. So I think that's mostly it. There is also just to finish one question about automation of the remote debug workflow in CLion, and I'll just try to answer myself that actually it could be a nice feature, and so why not? We'll actually consider it. So if you have more suggestions on how to enhance the remote debug or any kind of things in CLion, just submit us a feature request and we'll consider it for later. So I think with this, I will just take the screen and follow up with a couple of last slides. And so with this, that we're done. So thank you, Isa, thank you, Phil, thank you, Greg, for presenting. So just some piece of useful information in the end. So as I said, the video recording of the webinar will be available in a couple of days on our JetBrains YouTube channel, and we'll announce it via our social media and blog. Feel free to provide any feedback to JetBrains and Undo via Twitter. And if you'd like to know more about CLion, just go to jetbrains.com/CLion. So thanks everyone for joining us today. If you'd like to learn more about upcoming webinars, just subscribe to our Twitter, and we'll be happy to have you next time for the webinar. Thank you, and develop with pleasure.